You've got your credit card out, you're ready to make a purchase on the internet. How do you know that transaction is going to be secure? Let's talk about it. Let's pretend that I'm going to be on my laptop connecting to Amazon.com to make a purchase. Well, when I connect to Amazon, they're going to send me their digital certificate. And this digital certificate validates that Amazon really is Amazon. And when they were assigned that digital certificate, they also got a couple of keys. They got a public key that they make publicly available, and they got a private key, which they don't give to anybody. They keep that private. And we're going to use these two keys to do asymmetric encryption. In other words, we're using two different keys. They're asymmetric. And here's the logic. If I encrypt something with my public key, it can only be decrypted with my private key. And conversely, if I encrypt something with my private key, it can only be decrypted with my public key. Now, remember, Amazon's not going to give their private key to anybody, but inside of their digital certificate, they've got their public key. So they're going to send a copy of their digital certificate over to my laptop. And now the question is, how do I know that was really Amazon that sent me that certificate? How do I know it's not some bad actor out there on the internet? Well, Amazon has been validated. They've been vouched for by a CA, a certificate authority, such as VeriSign is the first one that comes to mind. And VeriSign, they have their own digital certificate with a public and private key pair. And the CA is going to sign or encrypt Amazon's certificate. So when this Amazon certificate goes to my laptop, it's all scrambled up. I have to decrypt it. And how do I decrypt it? Well, the CA has encrypted it with their private key, which can only be decrypted with their public key. Now, does my laptop have VeriSign's public key? Yes, it's built into the browser. So when my browser uses VeriSign's public key to decrypt Amazon's digital certificate, we know this really did come from Amazon. Now, as great as asymmetric encryption is, it is slower than symmetric encryption, where we're using the same key on both sides. So during this session, now that I've got this secure communication set up, during the session, I want to have a shared key. I want Amazon and my laptop to have the same key. How does that happen? Well, my laptop is going to come up with some big random number, and it's going to encrypt it using Amazon's public key, which I have in their digital certificate. And I'm going to send that big random number over to Amazon, and they're going to decrypt it because they can decrypt it with their private key. So now Amazon knows this big random number. I know this big random number. We now have a shared secret key, and we're then going to switch over to symmetric encryption for the duration of the session. And that's how we can rest assured that our credit card information is going to be safe traveling over the untrusted internet.